in this video, we're going to talk about simplifying our free body diagrams of systems of rigid bodies. So in this case, we have a two-force member. So what is a two-force member? So a two-force member is any rigid body that has two forces being applied to it. So in this case, we'll say we'll have a rigid body that will be 2 points, point A and point B. Well, we'll have two forces. We'll have one labeled force A, and we'll have one labeled as force B. Right? So these are used often in linkages and trusses. So two force members are. So our goal is to simplify our free body diagram. Okay, so the first thing here is we know, so the magnitude and direction of force A and B are unknown. So if we apply the sum of the forces along the x direction has to be equal to 0, and the sum of the forces along the y direction have to be equal to 0, we can come up with these two simplifications. We can say that force A and force B have to be going in opposite directions, and they have to be going parallel with one another. Right? So based off of sum of the forces in the x and the sum of the forces of y, we know that. So we can say that the magnitude of force A must be equal to the magnitude of force B, and they must be going in opposite directions. They'd be 180 degrees apart. All right. So if you summed all the moments about point A, and you set that equal to 0 in this case, or you could also sum the moments about point B, it doesn't matter, and you set them equal to 0. The only way this would be true for this case is forces A, all right, and force B would have to be going through both of the points of application. So that's the only way that they won't generate a moment about each other. So force B and force A must go along the line of action or go along the direction such that they would go through points A and B. Okay, so they'd be going along the same line, and they have to be going in equal and opposite directions. You could have also, the forces could also be going in along the opposite direction like this. All right, it doesn't matter which way you draw it, but they have to be going equal and they have to be equal in magnitude, opposite in direction, and they have to go through the line of action of the members. Okay.